Anemometer Construction Challenge. Hi, I'm Emily Neises, a 5th grader from Tunnel Hill Elementary School. Today I'm going to teach you on how to build a working homemade anemometer. An anemometer is an instrument used to measure wind speed. Weather forecasters use anemometers to forecast hurricanes and tornadoes. The first anemometer was invented by an Italian artist and architect, Leon Battista Alberti, in 1450. Later on, Leonardo da Vinci, a famous artist, architect, and engineer, improved upon it in 1483 to 1486. My first introduction to an anemometer was in the 4th grade science class. Ever since then, I knew I wanted to build one that worked. So let's get started. The first step in building an anemometer is to start with a strong base. I made my base from scrap wood from my father's shop. The bottom part of the base was constructed of a rectangular piece of plywood. The upper part of the base was made from a leftover piece of hardwood. A hole was drilled in the top of the upper piece that will eventually connect the rotor to the base. The rotor was constructed of a hardwood square. A hole was drilled in the center to help attach it to the base. A hole was drilled on each side of the hardwood square to attach a dowel rod. The dowel rods were recycled from my kite project and glued onto each side of the hardwood square. My goal of this step was to put both of these pieces together and have a smooth spinning rotor. On my first attempt, I glued a metal washer to the top of the upper piece of the base and connected the rotor to the base with the metal bolt. I found that it did not spin smoothly. My second attempt, I glued a nylon washer to the side on both sides of the rotor and connected the rotor to the base with a nylon bolt. Finally, a smooth spinning rotor. Finally, something needed to catch the wind. Now for the challenge. First, I tied styrofoam squares and attached them to the ends of the dowel rods, but they did not spin smoothly. Next, I attached to the ends of the dowel rods a plastic spoon. It did not catch enough wind to drive the anemometer. Finally, half of a plastic Easter egg was drilled and glued to the ends of the dowel rods. They were light, caught enough wind to drive the anemometer, and the concave surface minimized the air resistance. My anemometer was complete. In conclusion, I'd like to thank you for listening to my informational speech on how to build a working and homemade anemometer. Today I talked to you about what an anemometer is, when it was first invented, and how I constructed my own. Now I challenge you to go make one of your own. Give it a spin. Good luck!